when you are graphing inequalities, remember that you shade the region that fits the inequality. So you can do the 0, 0 test. When you have two equations that you're graphing, you are only going to shade the part where they intersect. So where they would both be shaded. So my suggestion is to shade each one individually and then really fill in where they overlap. So if I were to graph the first one, y is greater than negative 2x minus 5, I'm going to put a point at negative 5. And then will it be dashed or solid? Dashed. So I'm going to go down 2 over 1. And dash. And so if it's a greater than, I can do the 0, 0 test. It would be 0 is greater than negative 5. That's true. So that means I'm going to shade to the right. And I just do like a light shading for that one because I'm going to have to do a dark shading here in a minute. The next one, y is less than or equal to x plus 3. So I put a dot at a positive 3. Is it a solid or dashed line? Solid, and it has a slope of 1. And then I'm going to shade. I'm going to test 0, 0. So 0 is less than or equal to 3. That is also true. So it gets shaded down here. And then the part that I am looking for is the shaded region where they are both shaded. So if you want to shade individually first, make sure that it is clear that you are telling me the part that is shaded for both regions is really dark so that I can tell a clear difference. So I don't mind if you have some shading here and here, but this part that is double shaded is what you need to really shade it in dark. Otherwise I won't be able to tell. Okay, so try number 2. Okay, when I graph these, what did you notice about these two lines? They are what? They're parallel. And does their shading go towards each other or away from each other? Away. So is there any part of the shading that overlaps? No. So my answer would be no solution. No solution because they never intersect. So if there is no intersection between the two shadings, even if they have individual shadings, if there's no intersection between the two shadings, then your answer is no solution. All right, so we use linear programming problems. It's just a way of graphing inequalities, and they're in the form of word problems, normally to find a max or min value. So linear programming is a method of finding max or min values of a function. So what that means is how can I maximize this profit in this business? Or how can I minimize the cost of how to build this restaurant or how to run this store? So it's a way to max or minimize values, which later on leads into topics that you'll cover in calculus, but we only use algebra 2 for this. So it's kind of cool how you can do multiple things. Like you can do it in algebra 2 and in calculus, and there's different concepts, but you're solving for the same type of thing. So maximizing or minimizing a function. So we start with constraints, and constraints are just your inequalities. So those are the limitations on variables, and those are just your inequalities. And sometimes they'll be given to you, and sometimes you have to come up with them yourself. So they are phrased really similarly to the 3.2 word problems. where you were coming up with your own equations. So if it said, there are 150 people at the fair, and they're either children or adults, then you would say x plus y is equals 150. So you're having to come up with those constraints yourself sometimes. Then we have what's called the feasible region, and that's just the shading, the shaded area. And that's where all of the solutions are. So that's all of the possible ordered pairs that could fit into those constraints. But I just say the shaded area because that's the easiest way to understand it. The objective function, that is the equation that represents the goal of the problem. So you're always trying to do one of two things. You're either trying to maximize profit or you're trying to minimize cost. And then the last thing is your optimum point. So that's kind of the answer that you're looking for. So it's an ordered pair. At a vertice. Little geometry coming back. What's a vertice? Like a point. It's an ordered pair at a vertice that max or minimizes function. And so below, I have these right now for you. I didn't make you write them, but these are the steps that you're going to go through in a linear programming problem because this will definitely be on the test and it's going to be worth a big chunk of points. So it's a long process where you have a word problem and you have to follow these steps. So I would highlight these and kind of we're going to go through an example problem. But those are the steps that you have to take, and I'm going to check each part whenever I'm grading your test. So you want to identify the variables, write the objective function, write the constraints, graph it, identify the vertices, plug them into the objective function, and answer the question. And this may not make sense right now, but we're about to do some examples that show you what it looks like. And so in this word problem, it says a linear programming problem gives me these vertices as the endpoints of your feasible region. So we don't see the picture, it just gives us the vertices. And it wants us to find the max and the min values of my objective function. So we're going to take our vertices, each x and y value, and we're going to plug them into the objective function and find which vertice maximizes and then which function minimizes. And so I start with 0, 0. Obviously, when you plug in 0, 0, you'll end up getting 0. The next one is 0, 90. And so I would plug that in. 3 times 0 plus 4 times 90 is going to give me 360. 50, 80. So 3 times 50 plus 4 times 80 gives me what? 470, thank you. 70, 20. Should give you 290. And then 70, 0 should give you 270. So out of all of these, my objective or my vertice that's going to minimize my function would be 0, 0. So that's my min. And then the ordered pair that maximizes, and since you see this P right here, that probably means profit. So I would assume that the problem's going to want to be, what's your max profit? Yes.
And the last one is supposed to be 210.
Oh, 210. Thank you. And so which ordered pair is going to maximize my profit or my objective function? 50, 80. So when x is 50 and y is 80, my max profit is 470. And that's at the ordered pair of 50, 80. So the question may say, what do my x and y values need to be? And then the question may also say, what is my max profit? So my max profit is 470, but that is when x equals 50 and y equals 80. So try number 4, and I want you to give me the max and the min for those. So when you plugged in your ordered pairs, you should have gotten a maximum of 5,100. That was at the ordered pair 40, 20, and then a minimum of -70, and that was at 1040. Okay, here's another example. This is the next step. So now it's giving me the graph, and then it's also giving me the shaded area, which I call the feasible region. And so my first step is I want to identify the vertices. And so there are 4 of them, and I want to write down the ordered pairs. So I'm going to look at the bottom left first. That is at the ordered pair, what? The bottom left one. Good. -6, -2. And then if I go up, it would be -3, 5. To the right, 1, 5. And then the bottom right would be at 6, -2. So identifying vertices, those are your corner points. Those are the edges of, or the points where you have the inside is the shaded region. The next thing would be trying to find the inequalities. Another word for that is your constraints. This is kind of like finding the piecewise function, kind of like that, where you're looking at, so obviously there are 4 lines. I'm not going to make you do the domain and range, so that's nice. You're just finding the equations of the 4 separate lines and then creating an inequality for that. So I think the easiest ones to do are the horizontal ones for sure. So what is the line of this top line right here, if I were to create an inequality for that? And they're all going to be greater than or less than or equal to, because they're all solid lines. And so I see that purple line at the top. What is the line of that equation? Y equals what? 5. Y equals 5. It's shaded below that, so is it going to be a greater than or less than? A less than or equal to. So I'm going to say y is less than or equal to 5. And so if I did that for the top one, let's look at the bottom line. What would the inequality be for the bottom horizontal line? Good. Y is greater than or equal to -2. Okay, this is where the not tricky part, but like is a little bit more work comes in for the diagonal lines. So I need 2 things. I need the slope and then I need the y-intercept. But I am going to warn you that one of them has a fraction in it. So I'm going to do the one without the fraction first. And so I'm going to count the slope for this line right here. So I'm going to go up and over. So I go up 1, 2, 3, 4, 5, 6, 7. To the right, 1, 2, 3. So I'm just going to put a y here, and then I'm going to put 7/3 x. And I don't know the inequality yet, so I'm just going to leave a blank for that. Now, if I kept going up 7 more and to the right 3, would that make me hit my y or my y-axis? Y-axis. Yes. And what point would that be at if you kept going up and over? So right now it's at 5, at y equals 5.
It's gonna be 12.
And so I'm going to add 7 more to that. Go over 3, it's going to hit at 12. Now I need to decide, is it a less than or is it a greater than? Now I can test the point 0, 0. Right? So if I have 0 and 12, so 0 on the left and 12 on the right, which inequality is going to make that statement true? Less or greater? Less than, yes, less than or equal to. So I'm going to put a less than or equal to here. Now, let's say that it does not make a nice, neat little y-intercept and it's going to end up being a fraction. Sometimes there's no way to tell, but this strategy will work 100% of the time. And so I'm going to take, and you guys know how to do this because we did it on the last test. I'm going to take two ordered pairs. I'm going to solve for the slope, and I'm going to put it in point slope form and solve for slope intercept form. So I'm going to take this 1, 5, and I'm going to take this 6, negative 2, and I'm going to do the whole shebang right now. We're going to start to finish it. And I'm going to cross out A and B because I don't feel like those are necessary. I'm going to come down here and show the work. So I'm going to do y2 minus y1, 5 plus 2 over 1 minus 6. That gives me 7 over negative 5. So that's my slope. Which point looks easier to you guys? 1, 5 or 6, negative 2? 1,
5.
1, 5. That's what I was thinking. Great minds think alike, guys. Okay, so I'm going to do y minus 5. This is the point slope form equals negative 7/5 x minus 1. Y minus 5 equals negative 7/5 x plus 7/5. This is where it gets a little tricky when I add 5 to each side. I do not want you to write 5 and 7/5. That's literally my pet peeve in the whole world. It's the worst thing. It is. It's the worst thing I've ever seen. So if I want to create a common denominator, how can I rewrite 5? I'm going to put it as what? Instead of saying plus 5, if I want to make the denominator 5, then what's my numerator? 5. Not 5 over 1. I want my denominator to be 5, so my numerator would be... Like, instead of saying 5 over 1 equals what over 5? 25 over 5. Well, then I'm going to add the 7 in a minute.
Oh,
Yeah. This is just the 5. So instead of saying plus 5, I'm saying plus 25 over 5. So I'm just creating a common denominator. Because 25 over 5 is the same, that reduces to 5. I'm just creating a common denominator here and here. Then I'm going to combine the 7 and the 25. So it becomes y equals negative 7/5 x plus 32 over 5. And so now I'm going to put it up here, this line. And do I need a less than or equal to or a greater than or equal to? I need a less than or equal to because if I were to do the 0, 0 test, it would look like 0 and then a positive 32 over 5. I need a less than or equal to sign. So I personally don't think those are as bad as piecewise functions because you don't have to do the domain restrictions. You just have to do the inequality, which means you do the 0, 0 test.
How do you get 32 over 5?
So when I added this 5 over here to this side, 5 plus 7 over 5 becomes 32 over 5. If you did it in your calculator. Oh, okay. That was probably it. Okay, now here's the next step. Now we are given the constraints or the restrictions, and we're going to graph them, and then find the vertices, and then find the max or min point. So here we have the objective function. Here are my constraints, so I'm going to graph these. The first thing I need to do, x is greater than 0 and y is greater than 0. Those are always constraints because that just means you can't have negative values. So graphing those just looks like putting a solid line here and here. And when you're making your own problem, like on the homework, you always want to include these just to ensure that you don't have any negative values. So these are just always a given. They're understood. Yeah, they're always given. So it may not tell you in the word problem to say x is greater than 0 and y is greater than 0, but you always include them no matter what so that you don't have negatives. So then the next two, I'm going to put them in slope-intercept form. So y is less than or equal to negative x plus 16. And then solve the next one for slope-intercept form. You end up getting y is less than or equal to negative 1/2 x plus 10. So I do not have 16 points, so I'm just going to count by 2s for my scale. So to graph the top one, I'm going to put a y-intercept at 16, and it's a -1 slope, so it just goes down like this. Then for my second one, has a y-intercept at 10, and it's a slope of -1/2. So down 1, right 2, down 1, right 2. So this line looks something like this. They are both less than or equal to, so that means that the feasible region is going to be all in here. I just went down 1 and to the right 2. Okay, my next step is to find my vertices. So step number 2, find the coordinates of each vertex. So I have 1, 2, 3, 4 of them. And I'm going to write those ordered pairs out to the side. So my first one is 0, 0. The top one would be what? 0, 10. Then I go to the right, I have 12, 4. And the last one is 16, 0.
Why not 20?
Because it's not shaded. So I only shaded the part that they both overlap. Now I'm going to plug them in to my objective function, which is p equals 10x plus 15y. And I'm going to get my max and min values. So hopefully I get these right this time. You should get 0, 150, 160, no, 180, and then 160. Okay, so if those are good, then my minimum is going to be 0 at 0, 0. And then my max, and which is usually, since it's a P, I'm going to probably maximize my profit. You don't have any context of what the problem's about, but max value would be 180, and that's at 12, 4. Usually the coordinates that have two numbers, like instead of a 0 for an x or a 0 for a y, those are the ones that end up maximizing. And then the ones that have zeros in them are usually the ones with minimized.